My name is Amy Jones. I'm doing my final project on Nicholas Bourbaki. Nicholas Bourbaki is actually a pseudonym under which a group of mainly French mathematicians wrote a series of books presenting written descriptions of modern advanced mathematics. They began this journey together in 1935 with the goal of founding all mathematics on set theory. Their work led to the discovery of several concepts and terminologies still discussed today. Today I'm going to explain the very basic concept of set theory. Set theory is a set of collection of objects which are called members or elements of that set. If we have a set, we say that some objects belong or do not belong to this set. Sets can consist of elements of various natures, such as people, physical objects, numbers, etc. A set is an abstract object. Its members do not have to be physically collected together for them to constitute a set, but the membership criteria for the set must be well defined and cannot be vague. Some examples of a set might be students in a classroom, another set might be letters of the English language, another set could be natural numbers. I actually have an example of what a set looks like. So again, it could be something similar to this, which is a set of the letters of the English alphabet. One of the other things about a set is that they do not have to be in order. So for example, I have put the same set down here in a different order, and this would still be the same set as you see it here. There are different ways to classify sets. We have a null set, which contains no objects in the set. That's also represented by the symbol phi. We also have what we call a single set, which contains one object or member of that set. We also have the universal set, which would be everything contained in that object. So, for example, in this situation, I have actually used the letters of the alphabet, which would be the entire universal set. We also have the finite set, which would be a maximum number of objects in the set. In this case, I used the vowels of the English language. And then we also have what we call the infinite set, which would be basically an infinite amount of objects. So I used, in this situation, I used natural numbers to represent an infinite set, because natural numbers obviously go to infinity. There are three main ways to specify a set: by listing its members, also by stating the property of its elements, which in this case it could be the letters of the English alphabet, and there's also you can also specify a set by defining the rules which defines its members. Two sets are identical if they have exactly the same members of that set. There's also a nice method for visually representing sets, and we call those Venn diagrams. And this is an example of a Venn diagram where we have two arbitrary sets. Region 1 would be our vowels of the English alphabet. Region 2 would be our consonants of the English alphabet. And then region 3 is Y, which we have A, E, I, O, U, and sometimes Y. So for example, we have region 1, which is vowels, again region 2, which is consonants, the Y, and then all regions make up the letters of the English alphabet. So that's basically set theory in a very scaled down presentation. I hope you've enjoyed it, and I hope I have given you guys a good basic understanding of set theory. Thank you.